So let's take a look at determining if something is a function when we're given the equation. So when we have the equation, we need to find out if it's a function. We're going to solve for y. When we solve for y, we're going to make certain that there is not a plus or minus on the other side. Because if there's a plus or minus, that means that we're going to have a problem with it being a function. Because I can give you an x and I can end up getting two different y answers. So if you see a plus or minus, that's that two things. One's a plus, one's a minus. So automatically think, now you have two y's, so you don't know which is which. Okay? So we're going to cover 4 examples. And let's get started on those 4 examples. So the first example, we have x squared plus y equals 25. So I'm going to solve for y. All I have to do to solve this for y is take the x squared and bring it to the other side. I bring it to the other side by subtracting x squared from both sides. That'll remove it from this side with the y. What I'll end up with is y equals, if my stylus works, a negative x squared plus 25. Now I wrote that negative x squared because subtracting x squared means you end up with a minus x squared. And I put it on the front because that's how we typically do it. We write the variables up front and the numbers that are by themselves, that we call constants, in the back. So now that I have this solved, there's a plus, there's a minus, but it's not that plus or minus sign. Since it's not that plus or minus sign where everything's combined together, I have a function. Let's look at number 2. Number 2 says x squared plus y squared this time equals 25. So I have a y squared instead of just a plain old y. Now to solve this for y, I'm still going to have to subtract that x squared from both sides. Except now this time, instead of it saying y equals negative x squared plus 25, I have a negative x squared. Which I have a y squared equals negative x squared plus 25. So now I have to get rid of the square. And so we have to think back hard and remember, when you have something squared, you can get rid of the square by taking the square root of both sides. So that's what I'm going to do there. I'm going to take the square root of both sides. You get rid of, and that's whenever we're solving. If this would have been a cube, we take the cube root. A fourth, we take the fourth root. Whatever this exponent is, you change it into the index for your radical, and that's the root. Okay? So when I take the square root of y squared, I'm going to get a y. Square, square, knock each other out, you're left with a y. On the other side, when I take the square root, I have to remember to put a plus or minus in front of it. The reason why I have to put the plus or minus in front of it is because you have an even root and you're taking the even index. Whenever that's even, a square root, a fourth root, a sixth root of both sides, you need the plus or minus. And the reason why is when I take the square root of 16, I don't know if that's supposed to be, I'm sorry, I did it backwards. When I take a 4 and I square it, I get a 16. I take a negative 4, square it, I get a 16. So I don't know if when I got that 16, it came from the positive 4 or the negative 4. That's the reason why we put the plus or minus here. So I have y equals plus or minus square root of negative x squared plus 25. You have that plus or minus written there. It's not a function. Let's look at that next one. Number 3. Number 3 is already solved for y. When I look in front on the other side of the equal sign from the y, I don't see that plus or minus symbol. So this one's going to be a function. Something I want you to notice is to notice that I'm writing down the extra comments on the part that's the new part. Understanding the other part is what's considered prerequisite material. So I'm not writing down those comments that I'm making to kind of remind you of what to do, but I'm writing it down for the stuff that's new. Let's look at the last example. X plus y cubed equals 27. So I need to remove the x because it's on the same side of my equal sign as my y. So it has to go bye-bye. So I'm going to subtract the x from both sides to make it go bye-bye from the side with the y cubed. And it'll give me y cubed equals negative x plus 27 when I subtract that x from both sides. Now in order to solve this one, I'm going to take the cube root. The index is 3, so that's the kind of root I need. We call that the cube root. So I'm going to take the cube root of both sides. When I take the cube root of both sides, I no longer have to write that plus or minus because that's an odd. See, this 3 here is odd. I'll need to write the plus or minus when it's odd right here and here. And if we think of the cube root 8, I'm only going to get that from a 2. And the cube root of negative 8, I'm only going to get that as a negative 2. So let's finish our problem. So on this left side, I'm left with y. On the other side, I have the cube root of negative x plus 27. I do not see that plus or minus. So I have a function. Now let's take a quick moment to look back and give some little extra comment. Originally, you had the y. It had the y on number 1, and then an exponent of 1. On number 2, the y had a exponent of 2. On the third one, y had an exponent of 1. That's odd. And on number 4, the y had an exponent of 3. That's an odd exponent. Every time we wrote that y had an odd exponent, we ended up getting that it was a function. Whenever we had y to have an even exponent, we ended up with not a function. in terms of showing work on a problem like this, solving for y, that's enough work for me. If you choose not to solve for y because you recognize the pattern, then what I have written down at the bottom underneath those boxed in answers, that's what you give me for your work. In the course, we're required to show work, so you either solve it and show the work, or you write down what your shortcut was, and that'll work for your work. This is how we determine if an equation is a function.